Lesson 15, one-way ANOVA. So ANOVA is another parametric statistic. One way means there's one factor. The difference between ANOVA and t-test is the number of levels. T-test has only 2 levels. ANOVA has at least 3, but they can have 300. So the levels can keep going. And that's the big difference between ANOVA and t-test. So ANOVA can be a little complicated. Okay. You have main effects in ANOVA. That means just one of the levels can be significantly different than the others for it to be significant. One way to calculate this is to generate a source table first. This is a great idea. This won't be on the formula sheet, but it's something you might want to jot down in the test, bring it from your memory. Okay, and then as soon as I give you the test, jot it down. You have sum of squares, degrees of freedom, mean square, and the F ratio. Between subjects, within subjects. You can ignore the total if you want. So these 5 calculations are all very simple ratios. These 2 are a little more complicated. If you can just figure out how to solve these 2, the rest falls into place, and I'll show you right now. The F ratio is simply this, mean squares between, divided by mean squares within. These are all posted just below here. I don't want to be too confusing, but the F ratio is just MSBG over MSWG. Likewise, to calculate MS between groups, it's just this, SS between groups divided by the degrees of freedom of between groups. Simple ratio. Same thing with MS within groups. This one divided by this one. We see that in these formulas right here. MSBG is simple. These 3 formulas are all very simple. Okay? Let's talk about degrees of freedom. Degrees of freedom are fairly simple as well. This is just K minus 1, and K is the number of levels. How many levels do you have? Okay, this one is a little bit more different. Let's go down and take a look at it. So there's the degrees of freedom between groups, K minus 1, number of levels minus 1. And this one, degrees of freedom within groups, is just, if you had 3 groups, it would just be these 3. The reason we do ... and K here is if you had 4 levels, you'd have to have another one of these, or 5, you'd have to keep adding these on depending on how many levels you have. But if you have just 3 levels, it's just N1 minus 1 plus N2 minus 1 plus N3 minus 1. Okay, so these 5 formulas are all very simple to do. It's just these 2. Okay, so let's just focus on these 2, and you've already done the calculations in these type of formulas, so it shouldn't be anything new for you either. Let's look at sum of squares between groups. There it is right there. This is my version for the computer, but this is the printed version you'll get on the tests and in the formula sheet. It's at the end of your homework as well. So you just have, if you had 3 levels, right, it's just the sum of x of the first level, which you've done before, squared over the sample size. Sum of x of the second level, squared, and so on. And this is just, again, sum of x2, sum of x3, and you square it, and you add up all the total. So you can do this calculation. So once you do that calculation, once you get this one, and you get this one, you'll get this one. And you have the numerator of the F ratio already. Okay? Last one we got to look at is sum of squares within groups. So this portion right here, let me just show you right here. This portion right here, is the exact same as this portion right here. So if you calculate this first, just save that number and plug it right in here. What you do have to do for this section is make an x squared column, like we did in correlation or like we did in standard deviation, right? So this is not some fancy derivative. This is just the sum of x squared for the first group, the sum of x squared for the second group, and again, the sum of x squared for the third group. Do these numbers. Once you plug in the sum of squares within value, divide it by the degrees of freedom, it gives you the mean squares value, and then this divided by this is the F ratio, and you get your solution. That's the simple way, I think, of working on one-way ANOVA calculation by hand.